开始。
Hello, today we will have our internal English speech sharing, and we also want to share our parallel hybrid system to you. Today I will give a speech of introduction of Rawuns parallel hybrid system and project technical key points. Okay, this is the project. This is the product structure of the draft system. We can see here is the engine and the flywheel, the engine flywheel housing, and the engine ECU, driven planes, cloud plane, connect. This is a connect interface. And over here, we will see this is the flywheel housing of our drive chain, and this is the ISG motor. And also, we can see here, this is the electric transmission. We have 5 to 12 gears, electric transmission. And this is motor controller. And this is the electric clutch. From this view, we will see the system output shaft after the gearbox. The control logic is the TCU, control ECU, MCU, and clutch in battery electric mode, engine only mode, hybrid mode, power gen mode, brake regen mode, and limb mode. This is the complete parallel hybrid solution we provide to our project customers. Here is the control system. We have a VCU, dashboard, gear, a gear panel, radiator system, BMS, integrated controller, air compressor, air conditioner compressor, hydraulic oil pump, and air pump or brake. And also we provide the terminal management system and the analyzer tool and the accelerator and the LV, low voltage distribution unit. And over here, this is the battery system. Battery system, we mainly the main components of the battery system is the battery packs and the battery PDU, and we also provide the DC charger and the range extender. And over here is the drive chain. This is the parallel hybrid drive chain, and this is the drive the drive axle, and the engine. The black wire is the low voltage and the CAN wires, and the red one is the high voltage wires. And this is the complete parallel hybrid system solution layout or product structure. Okay, for the first mode I want to introduce to you is the battery electric mode. What means battery electric mode? Battery electric mode means the vehicle only drives by the battery. So we can see from here we can see the motor start and the engine engage and the brake regenerate start. And this is the blue one is the speed of the vehicle. The speed of the vehicle is like this. And we also have the yellow one. The yellow one is the engine speed, and the green one is the motor speed, the ISG motor speed. And we put the arrow here. Motor starts. The battery electric mode happens in here. It means that when the hybrid vehicle start to run at the very beginning, the engine is not at this very efficient speed, so only the motor can drive. It's very good that motor can drive the vehicle at the beginning. So in this part, the clutch is disconnect. This is the clutch of the engine is disconnect with the parallel hybrid drivetrain. The clutch is engaged. Engine idling or stalling, the motor alone drives the vehicle. So at the battery electric mode, the vehicle is started or driven by the IC motor. The engine doesn't drive the vehicle. This is the battery electric mode. Okay, we go to the next one. And this one is the medium to high speed stage here. It means that the vehicle is in the medium speed or high speed. The vehicle will require higher torque or power to drive. So in this stage, the engine may drive. The engine will provide the main power to the vehicle, and at the same time, we can see from here, the engine, the clutch connected, and the engine provide the power, the energy to the axle, and also the motor. The battery provide the power, the energy to the motor, and the motor also drive the vehicle. So in this mode, engine and motor, they work together. The engine will provide the main power. For example, this engine is 200 kilowatt, and this motor is only 100 kilowatt. So at this stage, the engine will provide 200 kilowatt plus 100 kilowatt motor power. So total power of the hybrid system is outputting about 300 kilowatt. So it means that the vehicle has bigger power to run, and this is the hybrid drive mode. Okay, we'll go to the next one. Okay, this one is engine drive only. The clutch is engaged and the engine is driven. If the driver's power demand is moderate, the ISG motor will not participate in the drive. It means that the engine already provide enough power to drive the vehicle at the medium to high speed stage. For example, in the highway, you know, in the highway situation, if the electric vehicle go at a very fast speed, the battery will drop very quickly. This is the nature of the motor. The nature of the motor is that if it runs at a very high speed, it consumes a very big power. The motor is not at its very high efficiency area. So, but at the same time, the engine is the engine power is the engine nature is like that. If for example, the diesel engine, if they go to the high speed, the efficiency is very high. So that's why if we drive at the highway, the ICE vehicle, the range is very long time. For example, if they go to the highway, it go to 1,000 kilometer distance, only consuming about, like I say, about 100 liter diesel. If the diesel efficiency is very high, but if the vehicle goes at low speed, the engine will consume a lot more fuel to run the vehicle. So at this stage, the engine drive only. The next one is engine power generation mode. It means that at this stage, the clutch is connected. The clutch connected, and the engine drive the vehicle, and at the same time, the engine is driving the motor, the IC motor. The IC motor can generate power to charge the battery. So it go like this way, and then it go like this way. So the battery can be charged while the vehicle is driving. This is the engine power generation mode. Okay, the next one is brake region. Brake region is that mean when we press on the brake pedal, or when the vehicle is slowly down, the motor will generate the power to charge the battery. It's very good for the brake system of the vehicle. If the vehicle is not hybrid, usually it will use a lot. It will have a lot of heat when they brake the vehicle. But if in the hybrid vehicle, with the help of the motor, the vehicle can slow the speed without having too much heat. And then we go to the next one. Next one is limp mode. What means the limp mode? The limp mode means that the battery is broken. The battery is not working, or the motor is not working. The system, the EV system have problem. At this time, limp mode can help. It means that limp mode, the engine still can drive the vehicle to some repair shop. Limp means that it's not working normally, but it still can work. This is the limp mode. Okay, and then this product features and application scenarios. Some advantage of our system. First one is the low cost, easy maintenance, low cost of use. And also the second one is the wide speed ratio range. The engine can operate in a low energy consumption speed range under various working conditions. And also the third one is the first gear. It has a large speed radio, stronger power, and a maximum clamping rate more than 30%. And the fourth one is long-term AMT limit capacity. Recommended scenarios. Number one, roads with combined operating conditions such as urban, suburban, and highway conditions. Second, roads with steep bridges and other conditions that require short-term clamping of the steep slips. Third one is the medium and long distance routes with few maintenance points along the way, such as suburban or intercity routes. And the main advantage is the good dynamic, good adaptability, good reliability, and good energy saving. This is the product features and advantage. And this is our parallel hybrid drive system model list. We have 1, 2, 3, 4, 5, 6. We have 6 models, and these 6 models we adapt to different vehicles from 7.5 tons to 120 tons. It's a very big range, and the rated power of the motor from 75 kilowatt to 130 kilowatt. We have gear ratio. This is 5 gears. This one, and And this one is 5 gears, and the top one we have 12 gears. Do you know why we put 12 gears here? For the engine, if the engine, because the engine speed range is not as big as motor, so at the hybrid parallel hybrid system, we still use multi gears as many as 12. It means that the vehicle can adapt to more situation. A lot of gears. We have 12 gears. And this is the first one. I'll go one by one. The first model. This one is application models 3 to 9 meter highway buses, public buses, 0.25 to 16 ton special vehicles. And this one is for the 4.5 to 12 ton light trucks, medium trucks. And the next one, this one is the application model is 9 to 12 meter highway bus, city bus, 16 to 25 ton vehicles, etc. And this model is applicable to 9 to 12 meter highway bus, city bus, 16 to 25 ton vehicles, and etc. And this is the big one. This one we use at the 25 to 60 ton heavy trucks. And it has 12 gears to adapt to many different situations. And the last one can be used to 60 to 120 tons mining dump trucks, wire body dump trucks. We can see this motor is not very big, but it's quite enough for hybrid use. It can save a lot of fuel in this application. Okay, then we go to the main the project technical key points. What we mean key points is that we need to focus, we need to pay attention to the technical key points in this kind of project, in the parallel hybrid project. The first one is make sure engine flywheel housing SEA number fixed. It means that this is the measuring of the flywheel housing, and this is all the models for all the flywheel housing of the engines. Start from 0 to 6. Our product is at this range. We have 6 models, and the first two small one is number 3, and the medium one is number 2, and the big one is number 1. So if you are interested in our system, you need to check your engine data sheet to check the flywheel housing. This is the housing, and this is the flywheel. Flywheel is inside. Flywheel is a running part of the engine, and flywheel housing is an interface to connect the engine. So make sure SEA number is from 1 to 3, and this is the flywheel housing number of our model. Second one is make sure engine ECU can be controlled by Rawuns TCU. Let's go to the very first one. The first one. Okay. The first one, like at the beginning, like I say, the control logic is TCU control ECU, MCU, and clutch in battery electric mode and other modes. This is our TCU. TCU need to control the ECU to make sure the speed and the torque of the engine is at the same required torque speed that the motor need. So we need to control the ECU. It means that our TCU need to control the engine. the running of the engine can be controlled by our TCU, by the CAN bus protocol. ECU should be with standard protocols such as ISO 15765-2. The protocol is SAE J1939. SAE J1939 is a very standard protocol of the CAN bus communication, and this is very normal. It's very normal to very normal standard of the vehicle industrial. It's very important that the CAN bus protocol of the engine of the ECU need to have two main messages. One of the messages is command message. No, this one is a feedback message from the ECU to TCU. Feedback, for example, feedback the torque or speed of the engine, and the next one is TCU to ECU. The command can message to the ECU. Key data: engine requested torque, such as percentage or in Newton meter. Maximum allowable torque, limit value. Actual torque output, feedback from the ECU. This is example. I put the example. It's one kind of the ECU we have from the other brand. Usually is like Bosch. I don't know the English. Bosch from the Bosch engine. Bosch engine is very famous ECU from Germany. Normally, most of the vehicle now use Bosch ECU standard. This is one of the Bosch ECU standard. In this protocol, we can see the CAN messages are shown at the document. So this ECU can be used in this kind of project. So we need to make sure the ECU can be controlled by TCU by checking the CAN protocols. Okay, and thank you very much for watching. This is my English speech for sharing our parallel hybrid system. And if you are interested in our product, please visit our website, and also we are very welcome to subscribe our YouTube channel. Thank you.